Hey everybody, this is Mr. Storm, and today we are going to actually write a script for a video game which will allow you to move your character around a screen. What you need to do first is come to the player movement assignment, which you are in right now because you're watching this video, so of course you're there. And you need to click this link to download the Maze Game project. So there we go. Now it's downloaded over here. Now, once it's downloaded, this next step is incredibly important. You have to extract all of the files out of this project, okay? If you try to open the project while it's still in this zip folder, it won't work, okay? You need to extract all the files out of here. So stop what you're doing, put your hands up, stop what you're doing, and pay attention to the next couple of steps, because they're critically important. So I have the folder open. Now, depending on the kind of compression software you're using, this next step might be different for you. But what you're looking for is a button or an option to extract your files. So I'm going to click Extract All. Now notice that this is already going to C# users, Storm, downloads Maze Game, because I've already extracted this project. And it knows where to put it. You want to put your project somewhere where you can get access to it. I would advise you just put it on the desktop of the computer that you're using. Actually put it inside a folder in the desktop, and that folder has your name on it. And then inside that folder, you're going to put this project. Okay, and then we're going to extract it. Now again, those steps might look differently for you. But just follow those steps essentially. Now, how do we open the project now that we've extracted it? Well, I'm going to open up my File Explorer here again, and I'm going to go to my Game Design folder, and inside my Game Design folder, I'm going to find my Maze Game, and inside here I have this, this number of folders here. The folder we're looking for is the Assets folder. And we want to go to Scenes, and we want to open up the Scene 1. Or Level 1 scene. So I'm going to double click on that, and it will open up in Unity. It may take a minute for it to open up completely, but that's the file I'm looking for. Now once it opens here, this is what our project looks like in Unity. This is a very simple game, as you can tell. We have our main character here, his goal is to get over here to this the end of the level. So we need to move them from here to there. That's the goal. And then there's a second level. If we go to the scenes here, we can double click on level 2, which is a bit more complex. Okay, so that's what we're going to eventually build up to. We're going to make that first level, and then whenever he wins, we go to the next level, and then the next level is a bit more complex. So how do we get this to work? Well, the first thing we want to do is we want to make sure that our character has a couple things. One, he needs a rigid body component in order for this to work at all, because the script that we're going to write accesses the rigid body component on this main character. Now it's a he. I call him a he. This could be a she. It's up to you. If you want your yellow ball to be a she, then she it is. For me, it's a he, because I'm kind of projecting. That's what we do when we play video games, right? We project our personality onto the character, even if it's just a yellow circle. So he is going to have a rigid body. Now, if I look over here in the inspector, which I believe my face is kind of covering it up. Let me move over here for a sec. Ooh, hello. If we look over here in the inspector, I can see that I have a rigid body 2D, which is what I want, because the rigid body 2D is for 2D games, and this is a 2D project. So you shouldn't have to add a rigid body 2D to this project because it's already there for you. But I do want to make sure that you understand it's important that we have that. Now, one thing that I want to point out here is we have mass. I can change the mass of my character, meaning I can change how heavy he is, and when he bumps into things, how much force does he apply toward those things. We can also change the gravity scale. Now, gravity scale is set to 0 right now, because when I play this game, I don't want my ball to fall down to the floor, right? I want him to stay where he is until I tell him to move, because this game is kind of like it's not a sideways game. It's kind of like a top-down game, if that makes sense to you. And that's pretty much it. Okay, so how do we create a script? Well, I'm going to make sure I have this guy selected, and I'm going to go down here to my, let me move my face again. I'm moving all over the place. Ooh, okay. Stop sticking to the corner. Okay. I'm going to go down here to my project folder, and I notice that I have this scripts folder that's empty. Well, let's put something in it. So inside this scripts folder, I'm going to right click in this area, in this open area here. I'm going to go up to create, and I'm going to choose C# script. Now it's important that you don't just hit enter and move on. You need to name this thing right away, because whatever you type for the name in this step right here is going to become the class name in the script. So I'm going to call this player controller. Now, if you accidentally just hit enter, then you're stuck with new behavior script as your class name. If you accidentally hit enter and then you decide, oh no, wait, I wanted to change the name, and then you right click and go rename, then you also have to rename the class name inside the script itself. Okay, just so you know that that's a thing. Now, at this point, we have a script, but it's not attached to anything, and there's really nothing inside the script. So let's attach this thing first before we move on to the next step. Now, there are a couple ways we can do this. We can either select our player, come down here to add component, which is, again, under my face. I got to find a better place for me to be. Click on this button called add component, and we can type script. Oh no, not new script. We can type the name of the script, player controller, right there, player controller script, which will add that script to my player. The other way I could do it, let me move my face again, is we can literally just drag this directly onto my player and let go. I'm not going to do it because I don't want to put two versions of the script on the player, but that's the other way you can do it as well. Okay, so now that my script is added onto my player, which again, my face is in the way, I'm just going to put myself right about, let's go in the middle on the bottom. That looks good. All right, so now that I know I have my script attached and everything's good to go, now I need to open up my IDE to start writing some code for this game. So I can just double click and it will open up the default IDE that I've established for this version of Unity. Now, the default IDE that comes with Unity is Visual Studio. So if I open this up, if I just double click, Visual Studio will open up. There are other IDEs that are a bit more, I don't know, I like them a bit more, and there are ways you can change it. So if you go to Editor or Edit and Preferences, and then External Tools, you can change which editor you are using just by finding the executable file for that editor. So if you have something like Visual Studio Code or MonoDevelop or something else installed on Unity and you would rather use that instead, you can. But for me, I'm just going to use Visual Studio. So I'm going to double click and Visual Studio will open up after a good bit of minutes. Okay. Beautiful. All right, so this is Visual Studio. All right, back to some programming, right? Okay, so with Unity, there are a couple things to remember when it comes to creating scripts. Now, first of all, this doesn't look like the C# scripts that we've been writing, because where's my main method? Wait, Mr. Storm, you told me in the last class, you told me in Computer Programming 1 that if we didn't have a main method, our code wouldn't even run. Well, yeah, for the console programs, that is true. For us, that's not, in Unity, that's not true, actually. The main method doesn't need to be there because Unity is handling our execution of the program. We don't need a main method, right? So the way Unity will run this code is essentially just top to bottom, line by line. Now, there are two methods that by default are input into a new script that you develop in Unity. These two methods are the start method and the update method. We may not always need both of these, but I'm going to explain what they both do. We can see by this comment here that start is called before the first frame update. What that essentially means is start will be called at the very beginning of this game object's life. Now, the game object I'm referring to is the object this script is attached to. So if you remember, this script is attached to our player object. So as soon as my player object exists in the game for the first time, we will run whatever's in start. Pretty easy. In update is called once per frame. Now, most video games in Unity are set to run at either 30 frames per second or 60 frames per second, depending on how you have it set up. So you're either going to run what's in update 30 times per second or 60 times per second, depending on how you have your frame rate established. So update will be constantly running, okay? Start will only run once. That's the big difference between these two. Excuse me. So let's actually start writing some code. Well, the first thing we need to do is we need to create a reference to that player object. Now, this is important because the script is attached to the player object, but we need to reference other components that are attached to the player object. Let me show you what I'm talking about. So the player object is what we are already attached to, but we're just a component. We're just a script. We need to access the rigid body 2D component, which means we have to back up a bit, reference the player, and then access the rigid body 2D component on that player. So here's how we do that. We're going to do this above the start method because we don't want to interfere with what's going on, and we're declaring a new variable, in this case a new object. And so we want to do that up above all the methods so that it's accessible by the other methods. All right, so I'm going to create a private. Now it's private because we only really need to access it within the script. And I'm going to call this, it's of type rigid body 2D. So I'm creating a new object of the type rigid body 2D, and I'm going to call it player. So essentially, we're going to create a new rigid body 2D. But more accurately, we're going to access a rigid body 2D that exists on our player. So this is just creating the variable. And then inside the start method, we're going to grab a reference to that. So I'm going to say player equals get component. Ooh, I almost spilled my water everywhere. That was scary. This is why you don't have liquids around computers, kids. Let's put it over here where it's a bit out of the way. Okay, so get component. I'm going to double click there. Get component. Now the component that we want to get is the rigid body 2D. And then I want an open and close parentheses at the end. Okay, so now essentially I have created a new object which holds this rigid body 2D component, and I've called it player. So anytime I reference player in the script, I know I'm referring to the rigid body 2D component that's attached to this same game object as the script. Hopefully I'm not going too fast. Hopefully we're following along roughly closely. You'll see how this works in just a second. Okay, so believe it or not, that's really the only thing we need in the start method, because at the beginning we just need to pull that reference to that object, and then we can move on. Everything else is going to be handled in the update. So in the update, we actually need to pull some values from Unity so that we know that there is some movement being made. But very quickly, I want to show you how movement works in Unity. So I'm going to write a line of code here real quick that is just going to make my ball move to the right. Okay? Without the player doing anything, it's just going to make the ball move to the right. This is not a line of code that you are going to use in your game. I'm just showing you how Unity works. So I'm going to use that player reference that I've established before, and I'm going to change the velocity of the player. Now, here's what this means, okay? This is important that we understand this. So I'm accessing the player object, which remember is just the rigid body 2D, and I'm changing the velocity of the player. Here's what that means over here in Unity. So if we see, we have my rigid body 2D. If I go down to info, I have an option called velocity. All I'm doing is I'm essentially just changing that value on this component through the script. So I'm referencing that rigid body 2D, and I'm going to change the velocity. And I'm going to set it equal to a new vector2.write. Do I need, is it capital R? No. What? I know what I got to do. I've got to set it so that it is, let's do this. So I'm going to do 1, 0. There we go. So here's what a vector2 is. A vector2 is essentially just a variable that holds 2 data points. It holds an x value, so left and right, and a y value, up and down, right? So whenever we're talking about direction, moving in a certain direction, we can use a vector2 because it's a 2D game. So what I've essentially said was, I want to move by 1 on the x, 0 by the y. Okay? So now I want to test out this script to see if my ball moves at all. I'm going to attach my script to Unity. So I'm going to click there. And it's going to take a second. It's going to build. I have no errors. It says it's ready. So I'm going to stop debugging my script because I know it's good. And then I'll come back over to Unity. And you're trying to attach a debugger. Okay, enable debugging for the session. I don't know why that menu popped up. Okay, so now I'm here. And when I click on my script, it's thinking for a second. There we go. When I click on my script, I can now see that I actually have that code that I wrote is now over here in the inspector. And when I play my game, my ball should start moving to the right on its own. And there it goes. So it's moving on its own. Now when it gets to the end, it has nowhere to go because there are colliders attached to the game object and to the level. So it's just going to stop moving. So far we've already created some movement in our game. But it's not very fun because we want to actually be able to control that movement as a player. So I'm going to go back to Visual Studio here, and let's get rid of, actually, this is fine. We can leave that alone for now. I'm just going to set these both to 0. And then let's talk about how we're going to create some actual player involvement here. So the first thing we need to do is we need to get references to the player input as they pertain to the horizontal and vertical axes, or the X and Y axes within Unity. So we need some input. Now in Unity handles input through the project settings menu. So if I go to project settings and I go to input manager, I can see that I have a bunch of these things called axes or axes. These are essentially just inputs like buttons or D-pad buttons or joystick, movement controls, whatever, right? It's just anytime I would push a button on a keyboard or push a button on a controller, there's an axis to handle that, and we can build our own. We can make our own axes if we want. Now, what I need is just a horizontal and a vertical axis. That's all I'm really caring about right now. And we already have one. We have a horizontal axis that is set to, it's already mapped to the A and D button and the left and right button on our keyboard. So AD, left, right. And we have a vertical axis that's already mapped to the up, down, and SW buttons on our keyboard. So those are perfect. We don't actually need to change anything about those. But what we do need to do is get references to them into our script so that we can get the value of those button presses and then make the game do something based on those values. So here's how we do that. These need to come in as float values. Here's why. Those input axes are anything from -1 to +1. Now, some of those buttons are just 0, right? 0 to +1. Some of them are dual axes, which means they can go all the way negative or all the way positive. But 1 is the max, -1 is the minimum. For these two buttons, 0 is the minimum, 1 is the max. So we're either going to be doing 0, which we're not moving at all, or we're going to be doing, oh, actually, no. For these two buttons, our minimum is -1, and our positive is -1, or our positive is +1. Our max is +1. Thank you. If we're doing -1, for example, on the y-axis, right, we're going up and down. If we're doing -1, we're going to be going down. If we're doing 0, we're not moving at all. And if we're doing 1, we're going all the way up. But the button press is a bit softer than just 0 to 1, right? There's a little bit of give in between. And that give is going to add some variability between 0 and 1. So there will be a decimal number. So this needs to be a float variable. So I'm going to say float h for horizontal equals input dot get axis raw. We want the raw because we want that variability in there as well, with no smoothing applied. And then the axis we're going to get is named vertical. We already saw these over in Unity. We saw that its name is vertical. Oh, excuse me, I got the burps. So we know the name is vertical. So I'm going to type in the name here, vertical, and then semicolon. And then I'm just going to copy and paste this for the next axis. Copy. I pasted. So we're going to make a V. Oh no, I already made a vertical. Never mind. We're going to make H the horizontal. And it's important that you spell these exactly, because if you do a lowercase h, it's not going to be able to find the right axis you're looking for. All right, so now we have, oh, let me scroll right there. So now we have horizontal and vertical, and then we need to apply these values, h and v, somewhere. Well, luckily, we already created our vector 2 here. And remember, the first one in the vector 2 is the horizontal, and the second one is the vertical. Okay, so at this point, I should be able to move my character around on my screen in my game just by pushing the arrow keys on my keyboard. So I'm going to push play, and then I'll stop, and then I'll come back over here to Unity, give it some time to think. Ooh. And it's already accepted my new code, and then I'll hit play. So now I can move. I can move diagonally, I can move up and down, but it feels a bit sluggish. It's a little bit tired, like it doesn't exactly go as fast as I want. So we're going to do one more thing to speed this up and make it a little bit interesting. Unity has this fantastic feature where we can create public variables, and then we can modify that variable inside the player window or inside the Unity editor window. So I'm going to create a new public variable. This is going to be a float, and I'm going to call it speed. And I'm going to set that variable to say 10. Now what I'm going to do is I'm going to take this speed variable and I'm going to multiply my movement here by speed. Meaning we're basically just going to speed up what we're doing so that 1 becomes 10. So instead of moving by 1 every frame, we're going to move by 10 every frame. So I'm going to attach this to Unity, stop debugging, and come back, and now I have that. Now the best part about this is if we look at our script down here, notice I have a new option called speed. That's because I created a public variable. So now I don't have to actually go back into Unity to change that variable. I can just adjust it here in the editor. This is such a powerful tool. I love it so much. All right, let's test our game. Oh, wow, that's way too fast. Okay, luckily it's a public variable. So I'm going to get out of play mode, and I'm going to come down here to speed, and I'm going to cut it in half. We'll say 5, and then I'm going to go back into play mode and test it again. Okay, that's a little bit more reasonable, maybe a little bit smaller. Now, here's the thing that I want you to pay attention to. Notice that the play button is still highlighted, which means we are in play mode. If I make changes to my variables here while we're in play mode, and let's go back to and I move around, I'm like, oh, that actually feels pretty good. Once I get out of play mode, all those changes I made, they revert, they go away. So don't make any changes you want to keep permanently while you're playing the game. Make sure you jump out of play mode before you're done, or before you change. Okay, at this point, our player movement script is finished. Now, in order to turn this in on Canvas, you actually don't have to turn in the whole project. All you need to do is turn in the script. And so I will show you how to go to find the script in the editor. Now, it's also important that when we're done with this, we save our project, or we save our scene, save our project, close out Unity, because we don't want Unity open while we're messing around with the files. Okay, so for me, my project was inside my game design folder on my E drive, and it was in Maze Game. Once you're in the Maze Game, you will see the Assets folder. You will also see the Scripts folder inside the Assets folder. Then you have the playercontroller.cs file. That's the file you're turning in on Canvas. Okay, turn in that file on Canvas, and then you're good to go. And I'll see you in the next week where we do even more fun stuff. Okay, this was a long one. Thanks for sticking with me through this whole thing. If you got through this, you're a champion, you're a winner. No one can ever keep you down. See you later.